we want to look at primitive and reference variables. These you will discover are really important. Primitives you're pretty much familiar with. Int, double, char, they are primitives. Then we have reference variables. Now reference variables tend to be objects. So let's have a look at things. When we create an object, okay, we declare a variable, and when we're declaring it, we say what class it's going to be of, okay? Nothing new to us. We use the new operator to create an instance of that class. Again, nothing new. Now the variable that we've created is set to the object's memory location, okay? And it becomes a reference to the object. So we create we've got our object and we've got the identifier, we've got, the name, etc. And it really points to that object, okay? Points to where it's located. So let's have a look at this. We have frog class. We create a frog object called Froggy, and we say Froggy is assigned new frog, Kermit. Okay, brilliant. And then we can tell Froggy to leap. So that's all making perfect sense to us. Now, let's have a look at the primitives. With primitives, when we've said int x is assigned 3, and then we say x is assigned 103, we've changed the value. We had direct access to that data, okay? And as we say, modifying the data, we modify the contents in the variable. With reference variables, we have indirect access to the data. So when we start to modify an object's data, the values there, we need to go with the methods. Hence, when you're writing your own classes, we're building and creating methods to access those variables. Now, in Java, a reference variable contains an object's address. Okay, so it's not the object, it's an address to where that object is stored. Now, we've got our froggy, string frog name, okay, and we're going to assign to it Froggy, so our object dot get name. So that was assigned there, okay, and now we say Froggy dot set name Kermit the second. What a lot of people then want to do is go, okay, Froggy, and Froggy2, and then I say Froggy is assigned Froggy2. So what did we do? We created two objects, and we created Froggy and then Froggy2, and we say, well, we want, a bit like if we say int x is assigned 3, int y is assigned 4, and then we say y is assigned x. So what would happen in this case, all right, is the value of 3 would be assigned to y. And when people do this with objects, they think the same thing happens. So we've got Froggy2, and we say that's assigned to Froggy, and we think like this has happened, but it hasn't. What has happened is, okay, assign Froggy2 to Froggy. So Froggy actually now has the address of Froggy2, okay? So, oops. What that means, well, if you think you've got someone's address, you can go and destroy their house. Hopefully you won't be doing that, but you could. And that's a bit the same on this one. We've got the address of Froggy2 in Froggy, and we can go and do things now there, all right? Froggy now has the object address of Froggy2. Parameters. These become really interesting when we start going down this line of parameters. So when we supply a primitive variable as a parameter to a method, okay, we get that data, and hence, if you recall, we can copy the value into that method, into the variable. No big deal. When we start to supply a reference variable as a parameter to a method, okay, the content contains the memory address of the data. So what we end up doing is we pass a copy of the address into the method. So we start handing out the object's address. It's going to be problematic. Want to go to arrays and then tie this into it, because arrays are reference variables, okay? Containing lots and lots of elements, sequentially located, and we can initialize them to any size. We access them via an index or a script. So what do we have here? Some code. All right, we've got int, the array is a new array of size 10. Int array, another array is assigned, and we've got the numbers into it. Two arrays, okay? Both have been declared. This one has also been initialized with values. And I say int array length is assigned another array dot length. And now all I'm doing is I'm looping through, okay? Just looping through another array and printing things out. If you can hear that, yes, that is a dog barking in the distance. So we need to start thinking about passing and returning arrays, okay? So we can pass an array as a parameter to a method, not a problem, okay? But what it doesn't do is it doesn't copy the array. It's a reference. So all that the method receives is a reference to the original array, okay? So if that method makes a change in the array that was passed into it, the actual original array is changed. You with me? I hope so. Okay. And arrays, well, we can also return them from a method which has its own dynamics to it. Let's have a look at some code. Playing with arrays, I've called it, and I've got int myArray 1 through 10. Okay, here I go system.out print myArray before method call. All right, and then print array. Okay, so I'm going to call a method called print array and I pass it my array. Now I call a method here called play with array and I pass it my array. What you'll notice is this method, play with array, isn't returning anything. How do we know? Otherwise something would be here like that, but it's not, okay? And then we print it out again at the end, and then I print a nice line for formatting. Here is the play with array method. And what do I do in that? Positions 8 and 9, I make changes to it. And this here simply prints out my array. So what I want to do now is I actually want to bring up this code. Well, I'm not going to bring it up. What I'm going to do, I should say, is I'm going to compile it. And it was Javac, and it was called Playing with Arrays. Just checking that it compiled. It did. Beautiful. And now Java Playing with Arrays. And if you remember the code, all right, let me take you back to the code. Okay, I'm just getting us back there here on the thing so it's easily spotted. Okay. So you'll remember I've created my array. Okay. And then I've printed this array. And if we take a look, here is my array before the method call. Okay, so before the method call, there it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I call play with array. Okay, play with array, and then my array after method call. My array after, my array after the method call. And you can see 8 and 9, elements 8 and 9 have been changed. 800 and 100. So we can see that was changed here. But you'll notice this is a void method. It doesn't return anything. It's a void method. It didn't return anything. It made an adjustment to the array, and back in the previous method in main, when we printed it out, the changes were there. And that's because it's passed by reference into the method. So it was passed by reference, a change was made, and because it's by reference, we're talking about the address of the array, and it's now been able to access the original array and make changes. Now, the next one that we have to look at is when we start to have to copy arrays, okay? Because if we need to pass things around and change things, but we don't want the original change, then we're going to have to copy an array. So what we're going to find is, and I think I just realized I've got probably an error in that code, which I will fix up for us in the code I release. Okay, but what are we doing? We've got our main, I've got all these things done, and then I go copy of an array, which I created up here, copy int array, and I tap through and you can see we're here. So the array comes in, all right, and now I've made a new array, okay, of equal to the length of this array, okay, equal length, and now what you'll see I'm doing is I am the array to copy. As I loop through, I'm assigning each element into the duplicate array. And then I go return array. So you can see with arrays, it becomes quite complex, but once you understand arrays and other objects are passed by reference, it becomes much easier, okay? Easy to write the code? Maybe not, but easier in your understanding. And that's why when we were writing our code for classes, we were returning copies of things because we're returning objects, all right? And we want to make sure when we're returning the objects that we are returning new objects rather than an address to an object that already exists.